Hi everyone, and welcome to this video from ExamRevision.ie. In this video, we are going to look at Leaving Cert Chemistry. We're going to look at the exam to prepare you for 2023 Leaving Cert. We're going to look at some tips. We're going to look at the layout of the paper. And most importantly, towards the end of the video, we'll look at some predictions for this year's exam. So to begin with, let's look at the layout of the paper. So the paper itself has two sections. We've got section A and we've got section B. Section A consists of three questions, and it is composed of experiments, where section B is made up of 8 questions, and that contains a mix of theory and experiments. This year, for your Leaving Cert, you are allowed to answer any 8 questions from the chemistry paper, so you don't have to worry about answering a certain number from section A or section B. You can answer any 8. Each question carries a total of 50 marks, and that gives us a total of 400 marks. So if you are aiming for a H1, if you're looking for a H1 in the Leaving Cert Chemistry exam, that would mean that you would need to be getting 360 marks at a minimum out of 400. So that means you can lose 40 marks in total, which is approximately 5 marks per question. So if you're looking for that H1, you have to be really precise and you have to really know your stuff and make sure you're getting in all of your keywords and reading the questions carefully. And that's where ExamRevision can come in. We can help you with that. We provide H1 standard notes on the complete Leaving Cert Chemistry course, including video tutorials, short 10 to 12 minute videos, outlining different parts of the course. The complete course is covered. There's self-correcting quizzes, exam questions, creator, and all of that. And we'll go through that throughout this video. So if we look at the timing of the Leaving Cert Chemistry exam paper, you have 3 hours to complete your paper, which is 180 minutes. If we break that down, that gives you around 10 minutes at the start to read through the paper and pick your questions. And this is really, really important because number one, it will help you pick your questions, but it will help settle you. It will help you read the chemistry. It will help you remember some stuff and get used to the language and get the thoughts flowing in your head. Then I always recommend to take 10 minutes at the end to review your paper. And to review your paper, that means you're maybe going over some stuff that you didn't get done on the paper, that you didn't have time to finish, or just reading over your questions to make sure you're happy with the standard of answering that you are giving. Each question then on the paper, I recommend spending 20 minutes on each of them. And if you follow this timing, you won't have anything spare to left over. So 20 minutes, after 20 minutes, when you finish your question, move on to the next one, because if you don't, you are spending unnecessary time on a question and you're going to lose out elsewhere on the paper. Because you have to remember, all questions carry equal marks. So even though they may have varying difficulties, you still should only be spending 20 minutes approximately on each. So let's take a look at section A. As I've said, section A will have 3 questions in it. They're all experiment based. And question 1 will always be a titration with 3 possibilities. It could be an acid base, it could be an oxidation reduction, or it could be a water titration. Question 2 is are the organic experiments. And question 3 I define as other. So let's take a look at these questions now individually and take a look at the type of content that comes up in each of them. So taking a look at question 1, as I've said, question 1 is made of titrations. Now, the first 3 titrations here, or the first 3 experiments that I put on this slide are very basic, mainly more geared towards ordinary level. If you're looking for higher level, you should be gearing yourselves more between 4 and 11. Okay, and you'll see with number 1 there, it's making a standard solution of sodium carbonate, and we actually use that further on in titration number 2 there, on using that standard solution of sodium carbonate to find the concentration of hydrochloric acid, and similarly in titration 5, which is your water crystallization. So let's just run through them quickly. Number one, making a standard solution of sodium carbonate. Here you are going to be looking for, they're going to be looking for technique when it comes to preparation. So it's important to know that, using your equipment, how to use it correctly, what is the correct technique for washing or rinsing, some of you may know it as, and all that correct equipment to use. Number two, they're using a standard solution of sodium carbonate to find the concentration of a hydrochloric acid solution. Number three, using a standardized hydrochloric acid solution to work out the concentration of a solution of sodium hydroxide. Number four, then, using a standardized solution of sodium hydroxide to work out the concentration of ethanoic acid in vinegar. So in this question here, you are going to, towards the end, maybe get a percentage volume per volume calculation. You're definitely going to have to calculate moles and grams, and that we are going to see in the majority of our questions. Question 5, or titration 5 here then, is to determine the amount of water crystallization in hydrated sodium carbonate. And 1 to 5 there are all based on the acids bases chapter. So I'm just going to put a little green dot beside them so we can categorize them. So they are from the acids and bases. The next ones then that we're going to look at is the redox reactions, and the redox reactions are 6 to 9. So we can use a standard solution of ammonium iron 2 sulfate to standardize a solution of potassium permanganate, to use a standardized solution of potassium permanganate to work out the amount of iron in an iron tablet, to prepare a solution of sodium thiosulfate and standardize it with a solution of iodine, or to determine the percentage weight per volume of sodium hypochlorite in bleach. Now, if I was to pair these oxidation reduction titrations off, I would pair 6 and 7, and I would pair 8 and 9. And the reason I pair them like that is they have similar techniques. Both 8 and 9 involve the use of sodium thiosulfate. So with 8 and 9, you are going to be thinking of your starch indicator. And that is important that you know your color change there. So you should be thinking of your straw yellow to your blue black to your colorless, where with 6 and 7, you're using your KMNO4, and KMNO4, you will remember that you should be reading from the top of the meniscus because it is a dark colored solution, and that is the only time you will ever read from the top of the meniscus. So that's why I pair them up like that. 10 and 11 then, 10 and 11 are your water titrations, and they are measuring the level of hardness in water using EDTA and measuring the level of dissolved oxygen present in water, which is the BOD, the biochemical oxygen demand. Now, a top tip that I have for you for your titrations is you definitely need to know your indicator and you need to know your color change, as I indicate down here. And you need to be able to do your calculations by first principles. First principles is the method that has been needed since 2015. So they will no longer accept the formula method at higher level. So you need to know your first principles. And if you want to know your first principles, we have you covered here at ExamRevision. So let's just take a quick look at the ExamRevision website. And as we can see here on the screen I've shared, we have the Leaving Cert Chemistry homepage for ExamRevision. And we can see that Unit 4 looks at titration technique and calculations. And if we click in there, we can see there's a video on titration technique, and there's also a video on titration examples, along with a presentation, and of course those H1 standard notes that you would be looking for. So if we just open up the notes there to have a little look, we can see here that I go through all of the equipment that you need. I give you tips, and then I go through the first principles calculations with you and give some examples. So that is all covered also in these videos here. So if we click into the titration calculations video, we can see here that I go through the first principles method in completion. I explain it for you, and I go through it step by step for an example in an exam paper. So that is the revision, exam revision content there for your titrations. So let's go back to our presentation that we have at the minute, and we are going to move on to question 2. And question 2 looks at your organic experiments, and in this one we can see that we have 9 in our list. So let's go through them. So the first two are pretty easy. Preparation of ethene and examination of the properties. And the second one, preparation of ethyne and examinations of the properties. So here in these two, I'm just going to put down tests for unsaturation. Both of the tests for unsaturation are using acidified potassium permanganate and bromine water. These are both the same test for both of these experiments. And then you're also going to need to know combustion. So number 1 in these, you need to know how to prepare them. And then you need to know the tests as well. Number 3 here is from rates of reaction. And sorry, not rates of reaction, thermochemistry, and it's looking at the heat of reaction between hydrochloric acid and sodium hydroxide. Number 4 is the extraction of clove oils from cloves and its isolation. So that is looking at steam distillation and liquid extraction. So you're looking at steam distillation and liquid extraction. Moving on then to number 5, you've got your soap. So base hydrolysis of an ester there for number 5. Number 6, you're looking at oxidation of phenylmethanol to benzoic acid, the recrystallization of it and its melting point. So there's 3 in 1 there. Number 7, you're looking at the properties of ethanol. Number 8, the properties of ethanoic acid. And number 9, you're looking at chromatography. So you're looking at your HPLC, etc. For question 2, I recommend that you know your reagents and your catalysts, and these must be labeled clearly. So you should have it labeled as follows: reagent and catalyst, so that you can ensure you're going to get your full marks in that question. If you don't label them accordingly, they will take them based off the labeling in the exam question. So if the question asks you for what are the reagent and the catalyst, they would expect you to write the reagent first, followed by the catalyst if you don't label it. So the easiest way to avoid all that stuff is to do your labeling. And secondly, I recommend that you know your percentage yield calculations. So that involves finding your theoretical yield and knowing how to find your limiting reagent. That will come up at the end of an organic question usually, and could be worth anything up to 15 marks. One year it came up as 15, but usually it's around 9 or 12. So it's important to know that calculation in order to ensure that you are securing your H1 mark in that question. And again, we'll look on the ExamRevision website in a few moments and we'll see that these experiments are scattered throughout the website, depending on what topic that they're in. Section A, question 3 then, this is the other experiment question, as I like to call it. It is usually made up of multiple parts. So in previous years, rather than just giving one experiment here, they've split the question up into maybe 3 parts and examined snippets of 3 different experiments. Possible experiments that can come up on this question are the flame tests, redox reactions and displacement of metals, tests for anions, the relative molecular mass of volatile liquid, monitoring the rate of production of oxygen from hydrogen peroxide in a manganese dioxide catalyst, studying the effects of temperature and concentration and the rate of reaction. So 5 and 6 there, I'll highlight them. They both come from the rates of reaction chapter. Number 7 is equilibrium, looking at Le Chatelier's principle, while 8, 9, 10 and 11 all come from water, where you've got your free chlorine using a comparator, your total suspended solids by filtration, total dissolved solids by evaporation, and determination of the pH of water. So that is question 3. Really, on the day, it's just going to depend on what comes up as to whether it suits you or not. So make sure you read the question very carefully to see what experiments come up, especially if there are multiple parts. So that is section A of the paper done. Let's move on to section B. As I've said with section B, there's going to be 8 questions in section B, and there will be some choice within those questions. So as we can see from the slide here, question 4 offers internal choice, as does question 10 and 11, but questions 5 to 9 do not. So if you choose any question between 5 and 9, you must do the complete question in its entirety, where with question 4 and question 10 and 11, you do have some slight choice. You may be able to pick certain parts. So let's dive in and take a look. for questions 4, 5, and 6. So we're going to start with question 4. There will be 12 parts in question 4, of which you have to answer 8. And part L of this will be from the option part of the course. So my tip here is you will be marked on your best 8. So I recommend that you answer as many parts as you can, because there is no negative marking. The question is worth 50 marks, and you will get 7 marks for your first 2 correct answers, and then 6 marks for your remaining 8, giving you a total of 50. If you answer 10 parts and you only get, if you answer 10 questions and you only get 8 of them correct, that's fine. You still get your 50 marks. And also that should be 6 questions at 6 marks. Apologies, 6 sixes is 36. So if you only answer 8 and you get 1 wrong, that means you're only getting marks for potential 7 there. So you're not going to be getting your full marks. So answer as many as possible. There's no negative marking. If you're looking at doing question 4, they're usually small particular questions. And you will be looking there at, I would think you could be looking at mole conversions. You're also going to be looking at definitions. And you may also be looking at electronic configurations and some sort of theories from the atom and the periodic table, etc. Now, question 5, we move straight on. It becomes the atom periodic table, including trends, bonding, and radioactivity question. So one thing I do think about this question is it is quite difficult to obtain full marks in this question. It is very specific and it is very wordy. There's often not a lot of maths in this question. So if you don't like the maths part of the chemistry course, this could be a question for you to go to. But it is quite specific in its marking scheme, and the marking scheme usually on that is quite tight. You definitely need to make sure that any definitions you have are word perfect, and you definitely need to be including all of your keywords in answers there. Question 6 then, it's part of organic chemistry, and it looks at fuels and thermochemistry. And a tip that I have for question 6 is you definitely need to know Hess's law and the heat of neutralization calculation, as one of them will definitely appear on the paper. So if we go back to the ExamRevision website, we can see here that we have a folder, Unit 7 on Organic Chemistry. And when we click into that folder, we can see we have 2 subfolders called Families and Reactions, or Fuels. So I've said question 6 is based on fuels. So if we click into that, you can see we have several videos here. We've got some on alkanes, one on alkenes, alkynes, and benzene. You've got your experiment there, preparation and properties of ethene and ethine. We've got fractional distillation and production of hydrogen gas, and then we've got octane number from fuels. We've got 2 quizzes there, self-correcting, one on hydrocarbons, one on oil refining. We've got a PowerPoint presentation on fuels, and then of course we have those H1 standard notes on fuels. So if we click into that, we can see and we give a good introduction. We go through each of the families, how to draw them, their properties, how to name them, etc. Then we go down into the experiments and we look at the different tests for them. And then we move into oil refining. What is fractional distillation? And natural gas, we look at octane number, factors that affect octane number, etc. So that content is all in there for you, along with our videos. So if we go into octane number, here we have a 9-minute video explaining all of the content on octane number. So it goes through isomerization, catalytic cracking, etc. All done in video format for you. So that should help you revise then for question 6 on the exam paper. So moving back then to our presentation, we can see now that we'll move on to questions 7, 8, and 9. And with questions 7, 8, and 9, one of these will be an organic chemistry question looking at the families and the reactions. And I would definitely say that this will probably be question 8. And if you were doing this question, you need to know the families, in particular their functional group in order to be able to identify them. And you need to know your mechanisms. So you need to know substitution, you need to know addition, you need to know conversions of oxidation reduction within organic chemistry, polymerization, etc. So as I've said, top tip, know your families and know your reaction types, including mechanisms. And again, you're going to need to know your reagents and your catalysts, in particular for your oxidation and reduction. What is the reagent and what is the catalyst? And again, labeling is very important here. The other two questions out of 7, 8 and 9 will include, but are not limited to, the topics of rate of reaction, equilibrium, water, acids, bases and pH. So the main reasons that we've picked these topics, these are the ones that have come up most frequently. They're not limited to these topics, other ones could come up, but these are the main ones that come up in question 7, 8 and 9, whichever one of those is not your organic question. Moving on then to questions 10 and 11. As I mentioned earlier on in the video, questions 10 and 11 do have internal choice. And as part of that, question 10 will have 3 parts, of which you have to answer 2. And question 11 this year will have 4 parts, of which you have to answer 2. And part D will be from the option. So if you're not covering the option part of the Leaving Cert Chemistry course, you can still do question 11 because there will be 4 parts in it, of which you can answer 2. You'll only be able to answer a possible 3 of those parts. So you still have 2 out of 3. So that is still a possibility for you. Common topics that come up in this question are atomic theory, equilibrium, acids, bases, pH, stoichiometry, water, electrochemistry, organic chemistry, properties of gases, and oxidation and reduction. And the parts of these questions are usually worth 25 marks each. So that is why you have to answer 2 parts in each question, because 25 by 2 gives you your 50. So there will be 7 parts in total between these 2 questions, with a mixture of the topics that are shown here, and you will only have to answer 4 of those 7 parts. Now, it is worth noting, these are typical topics. This is what usually comes up in this section, but it's not guaranteed that it's just limited to those topics. So some top tips that I have for you. This year, you have to answer 8 questions, and I recommend that you answer 8 questions only. It is quality over quantity. As I said, if we looked at the breakdown, we have 10 minutes and 10 minutes for reading the paper at the start and the beginning, and then we have 20 minutes per question. If you are able to do 9 or 10 questions within the Leaving Cert Chemistry exam, your answers for your other questions are simply not detailed enough, and that's it. That's as simple as it is. You should only have time to do 8 questions on that paper. If you're answering them in enough detail and with sufficient content knowledge and demonstration of chemistry's knowledge and skills, you should only have time to answer 8. If you've time to answer a 9th question, okay. But realistically, you should only answer 8, because any time that you spend on doing a 9th question, that means some of the time you've spent answering a question is going to be completely disregarded, because the question won't be counted. The examiner will correct all of the questions you do, but they can only give you marks for your best 8. So whatever 9th question you don't get enough marks in and isn't counted, I think that's wasted time in the exam, and you will be better off to spend your time perfecting your top 8. When it comes to calculations, you need to ensure that you show all steps. So that means that particularly you need to show calculations for MR, and you should show all steps in your calculations, even if you use a calculator. Show the division that you're doing, show the multiplication that you're doing. So when you're showing your molecular mass, you need to include the addition, show what you are adding. So it is not simply enough to say, let's say that the MR of H2O, it's not okay just to say 18. You must show 1 + 1 + 16 = 18, because that then indicates to the examiner, well, this student knows the atomic mass of hydrogen and they know the atomic mass of oxygen, and they know the total of that is 18. Where if you put down, let's say, for example, you said the MR of H2O is 20 by mistake and didn't show your workings, you're going to lose marks there. So, but if you've shown your workings and you said 1 + 1 + 16 = 20, you'd still get the majority of your marks, because the examiner could see what you were doing and saw that, okay, this person just made a mistake as they were rushing through the paper. Diagrams should be fully labeled. That means you should have a minimum of 5 labels on any diagram that you draw. Use a ruler. sketching, etc. It doesn't have to be a work of art, but if it's neat and it's very clear and easy to read, the examiner will be able to correct your paper nice and quickly. Use graph paper for graphs. That shouldn't be a problem now because the new Leaving Cert Chemistry booklets have graph paper within them, just to make sure you draw the graph on the graph paper. And it has happened in 3 previous years that you lose -3 marks for not using graph paper. Okay. So it's important that graph paper is used correctly. And when you're drawing your graphs, make sure you have salt on your graph. Okay, you need to have a scale, you need to have axes, there needs to be labels, and there needs to be titles. Labels includes units. Okay. Next top tip, answer what is asked. So I always tell students underline keywords in a question. Okay, so if the question, it's important to know for the, let's say, if a question says name versus describe. If it says name, you don't need to spend 10 minutes writing down a description. The only marks you're getting there is for the name. Okay, but if you're asked to describe, you need to have a certain number of steps. And what I would also say with you in a question is divide the number of marks in the question by 3. This will tell you how many pieces of information you need. So for example, a 15-mark question would need at least 5 points. A 12-mark question would need at least 4 points. And as always with any exam, a neat and tidy layout is favourable. The examiners want to be able to read what you've written. They don't want to have to try and decipher what it is. If it's easy to correct, that means the examiner will have an easier time and you'll be able to pick up marks much more quickly because the examiner is actually going to be able to read what you have written. So 2023 predictions. This is probably what you're all here for. So let's take a look. I'm going to give predictions for questions 1, 2, and 3, and then a little bit of general prediction content for the paper. Just before I start predictions, I would like to say to you, I am in no way associated, and neither is ExamRevision, with the State Exams Commission. We have no clue what's on any of these papers. We are just basing these predictions off previous trends, what has come up in the past, and what we think may come up just looking through the exam papers. And as you can see, that's what I've done for this. We're looking at question 1 at the minute. I've gone through the exam papers from 2011 to 2022, and I've listed out all of the experiments that have been asked, the topic that they belong to, and what unit you can find them on ExamRevision. So for example, let's take a look at 2011. It was the percentage of sodium hypochlorite in bleach. And with that percentage of sodium hypochlorite in bleach, we know that that comes from the redox section of the chemistry course, and that can be found in unit 6 of ExamRevision. So if we move to the ExamRevision website for a moment, what we can see here is we can see unit 6, oxidation reduction. If you click on that, I have a theory section on oxidation and reduction that goes through all of the theory, including balancing redox equations. But the main one that we're interested in at the minute for question 1 is the oxidation reduction titrations. There is a video on each of those for you to go through. There's a quiz and there is a presentation on H1 standard notes. Within these videos then, we have top tips for your titration, methods that are needed. We go through indicators. So you'll see here that at the start of every titration, I will have a table like this, indicating what's in your burette, your conical, your indicator, and your endpoint. We go through some tips, and then we also go through a calculation the whole way through to the end with you. We go through several in this video. There's example 1 there and example 2. So that is to show you how useful the ExamRevision website will be for your preparation for your exam, along with these predictions that we are providing with you or for you. So you can see here, if we look, redox has come up 1, 2, 3, 4 times in the past 10 years. Acids and bases has come up 4 times in the past 11 years as well. And water has come up 4-ish times as well. So what I think is going to come up this year is the iron tablet. If we take a look at that experiment, the iron tablet hasn't been asked in an awful long time. So iron tablet or an iodine thiosulfate titration. So I definitely think one of those is going to come up. Or it could be ethanoic acid in vinegar. And the reason I say that is that has not come up since 2016. So it's either of those two, but I would be leaning more towards the iron tablet, just based off its frequency in appearing on the paper. So moving on then to question 2 for your predictions here. This, we know question 2 is the organic chemistry question, and it is your organic chemistry, all of your experiments that are in that. So we can see from our table that for organic chemistry, all of your content for organic chemistry, it can be found in Unit 7 of the ExamRevision website. So if we just take a look at that for one moment, you can see here I've opened up Unit 7 already for you on organic chemistry. And we can see in here we've got experiment, preparation of soap, experiment, reactions and properties of ethanol, reactions and properties of ethanoic acid, which is your carboxylic acid. And we also have here the production, recrystallization and melting point of your benzoic acid. When it comes to organic chemistry for ethene and ethine, these can be found in the fuels section on our website, preparation and properties of ethene and ethine. So that is all on the ExamRevision website for you. Again, helping you achieve that H1 in chemistry that you're looking for. So if we come back to our 2023 predictions for question 2, we can see that I have predicted that clove oil or ethanol and ethanoic acid will come up. The reason I've picked clove oil is clove oil hasn't really appeared since 2018. So I think it could be a long question on clove oil, including the isolation and liquid extraction. But we have started to see a blend in the past few years in question 2 that they're bringing up more than one organic chemistry experiment. And if that's the case, then I think they may pair it with ethanol and ethanoic acid. But also be aware, benzoic acid is quite a frequent asker there. But I definitely think clove oil is a good one to know there. Then the last little bit of predictions that we'll do is for question 3. As I said, question 3, that's the other experiments question. So here we got questions from, the question is split into multiple parts, and the parts are usually based off a multitude of experiments on the course. So I think for 2023, we're looking at the relative molecular mass of a volatile liquid or heat of reaction. And that's purely because neither of those have come up since 2018, 2019. Rates of reaction has come up in the past 2 years, sorry, in 2022 and in 2020. And I'm just going to correct here for 2021, that was redox. So I will edit that into this video. So that is redox. So if I just edit that in, so I just added that in there for you, Unit 6. So I think it will be the relative molecular mass of volatile liquid or heat of reaction. And I've listed here for you all of the units in which you can find these experiments on the ExamRevision website, just for convenience. So the last thing, some general predictions for section B. As I've mentioned already, fuels is guaranteed to come up, as is organic. You need to know your mechanisms, your families, your functional groups, and the atom and the periodic table are also guaranteed. So they are 3 questions that you are definitely going to get, which could add up to 150 marks out of 400, which is 37.5% of the paper we definitely know is going to appear. When it comes to other long questions, I do think water may come up as a long question this year, with a particular look at sewage and water treatment. And I think rates of reaction will appear as a full question in section B if it doesn't come up in section A. And then lastly, you're going to see equilibrium or acids and bases. One of these will be a full question, or they may bring them up as a blend this year, as equilibrium was asked as a long question last year. Now, as I've said, these are all just predictions. We have no real clue what's going to come up until the day you open the paper in June, but these are just to guide you based off previous trends and what has come up in the past. So that's it for this exam revision video. Thank you very much for joining us today. I wish you the very best of luck with your exam, and I hope that everything goes well for you with your studies for the rest of the year. And don't forget, for H1 standard notes, bite-sized videos on all parts of the Leaving Cert Chemistry course and self-correcting quizzes, examrevision.ie is your one-stop shop. So hopefully I will see you there and see you in another exam revision video very soon. Thanks a million, guys. Best of luck.